Hello and welcome to the Biomechanics Sports Project, specifically on tricep extension in the motion and throwing darts by Theo in Period 5 AP Physics 1 at Berkeley High. So like I said, this is particularly on tricep extension, which is, well, you can see here this diagram of the back. This is the scapula, the shoulder, and these muscles that extend down the forearm, the back of the arm. There's the lateral head of the tricep as well as the long head of the tricep. And, well, they're separate parts of the muscle, but they work together to accomplish a collective goal of elbow extension, which is what we'll be looking at in this diagram. As you can see, the tricep is right here. And when you extend the arm, it looks like this, back to here, back to extended. That's basically how the tricep works. So you can think of it like these levers. It's these two bars essentially with string wrapped around, and if you can see this force on the right that's being applied, well, it's going to straighten the arm, like you can see here. It's going to straighten the bars out using the rotation around that axis. And, you can see here that your rotational inertia is going to be 1/3 ml squared because you're rotating a rod around its endpoint. For this, we're just worrying about the forearm function. And here's your L value and your M values, depending on the length of my forearm and the weight. These are the values that I obtained, 1.19 kilograms and 0.42 meters. So using these values, you're able to calculate I, which comes out to about 0.069972 kilogram meters squared. You obviously get this when you square the meters. And here's a little diagram of what it looks like to be throwing the dart. Obviously, you have an X value, which you are standing away from the wall. Also, a height value that is the height of the dartboard above the ground. Or you have a V0 vector for your throwing of the dart, as well as an angle of theta, which you're throwing it at. This height was obtained with the Measure app on iPhone that we'll see later, as well as this X value. And this theta value is actually obtained using estimation for this extra distance that the dart would be without gravity if you just threw it out. I used an inverse tangent to get about 26 degrees of theta, which seems reasonable. Here is a diagram of what the torque essentially would look like. It also can equal I theta in addition to the cross of R and F. If you use the right-hand rule here, you can see that with these two vectors here, you get a torque force that is coming out of the paper, which you can use this notation here. So now we're getting into the measurement part of the video. We are using this measurement app in the iPhone. Obviously, if you just type measure, it should be pre-installed on the iPhone. We have a very faint line in the ground here for where you're supposed to throw the darts from in our garage. I'm just going to take the thing here and basically stretch it out to the edge. For our first reading, we had 7 feet and 4 inches. Okay, let's do it again, just for accuracy's sake. Get to that line again. Again, it's very faint. And we stretch it out right there to the edge, and this time it says 7.5. So we're going to go with 7 feet, 4.5 inches. Now for the height. We got a few experimental values for this height, so basically what I did was I went back and basically compared the height of the middle of the dartboard to my actual height because it turned out to be very close. As you can see, that 5.2 reading is not exactly accurate. We got some that were higher, some that were lower. So we're just going to skip ahead to where we started getting better measurements. So here you can see me comparing my own height, which is almost 5 feet 8 inches, to the height of the dartboard. When extending my hand out, it essentially went to the bullseye, maybe a little bit lower. So we're going to call that 5 feet 8 inches. So here I'm just including a clip of me throwing the darts, just so, it's easier to visualize what's actually going on. And in case you haven't played darts before, I'm just throwing these 3 darts right here. It's over quick, just like that. But yeah, that is pretty much it. That is the depiction of 1, what it is actually like throwing darts, 2, how you are using the tricep muscle in your arm to essentially extend that forearm, extend that elbow joint, pull back that string from those levers, and actually get that throwing motion that you want. I genuinely hope this video was helpful to you to understand this concept and to hopefully even be able to better apply it in your own biomechanical endeavors. Thank you for watching.